So in this video I'm going to explain exercise 1D from the Matura exam from 2017, I suppose. So we are dealing with the following function. You see here the function equation. The function is defined by g of x equals x squared minus 1. So here on the left you see a picture of the situation. This here is the graph of the function we are dealing with. And so now what is our problem? Our problem is the following one. We are dealing with the following triangle here, here, here and here. So this triangle is defined by two tangents. One tangent here, another tangent here, and the x-axis. So the triangle we are dealing with is defined by two tangents and the x-axis. So what's our problem? Our problem is we want the area of that triangle to be minimal. So of course, since we want the area of something to be minimal, we are dealing with optimization. So let's see. Well, we want the area of this triangle to be minimal. This means we need to find a formula for calculating the area of that triangle. So let's see. This triangle is defined by the two tangents and the x-axis. The two tangents intersect here in this point S with coordinates 0, Q. So this point S here lies on the y-axis. Okay, so the area of our triangle is given by the length of this line here times the length of this line here. Well, because this line here is just a half of the length of the whole baseline of the triangle. So the area of the triangle is given by length of this line, which is the absolute value of Q. Well, we need to take the absolute value here because this Q here, the coordinate of the y coordinate of S, is going to be negative. So we need to take the absolute value here, and moreover we need the length of this line, so maybe here let's label this point A. So the area of the triangle is given by the absolute value of Q times A. Okay, so let's see. Well, as already said, Q is the y coordinate of the point of intersection of the two tangents. A, well, what is A? A is the point of intersection of the tangent T. Well, I'm calling this tangent here T. We're not going to need the other tangent, you will see. So A is the point of intersection of T and the x-axis. Q, or S0Q, is the point of intersection of T and the y-axis. So if you consider these 2 points here, well, the only thing we are going to need is the equation of the tangent. Afterwards we can find the point of intersection with the y-axis as well as the point of intersection with the x-axis. So let's start. A tangent is given by a linear function, so we know that the tangent has an equation of the form y equals m times x plus q. So let's see, what do we know about tangent? First, m is given by the derivative of function g at point P. So let's maybe say P has coordinates u. We don't know anything about the x coordinate of P at this point, so let's just say that x coordinate is u. So m, the slope of the tangent, is given by the derivative of g at point u. Okay, so derivative of g equals 2 times x, which means m equals 2 times u. So this is m. What else do we know about the tangent equation? Well, we know that point P lies on the tangent. And here, this is the most important step here in the whole exercise, and we've used that step several times. P not only lies on the tangent, P also lies on the graph of G. What does this mean? Well, this means we know a lot about the y-coordinate of P. So, because P lies on the graph of G, we know that the y-coordinate of P is given by u squared minus 1. Okay? Moreover, that point lies on the tangent, from which it follows that u squared minus 1 equals, just plugging in everything we have so far, 2 times u plus q. So this means u squared minus 1 equals 2 times u squared plus q. Taking this on the other side and solving for q leads to minus u squared minus 1 equals q. And this is almost everything we need, because now you see here we have m expressed with the help of u, we have q expressed with the help of u, so we can express our tangent equation just with the help of u. So t equals 2 times u times x minus u squared minus 1, and this is my tangent equation. And now I can sort. Now I have the tangent equation and I can calculate a as well as q. Let us start maybe with a. Well, a is the point of intersection of t and the x-axis, so we take the tangent equation and set that equal to 0. Like this, and then we solve for x. Dividing by 2 times u leads to, and this is a. So here I have a. And q, of course, q is already given because q is up there. So q is minus u squared minus 1. And so I have everything I need. Now I can take these two things and plug them into the formula for the area. And of course, as I said before, here we need to take the absolute value, because this number here is of course negative. So we need to take the absolute value here, and the absolute value here of this is just u squared plus 1. So let's plug these things into the formula of the area. The area of the triangle is given by a times absolute value of q, which is u squared plus 1 divided by 2 times u squared plus 1. Okay, so we can combine these two expressions, so this leads to u squared plus 1 squared divided by 2 times u. And now the most difficult part of the exercise is done, because now we have a formula for the triangle containing just one single unknown, in this case u. So this is f of u, our function, and we take the derivative. Of course, you can simplify this if you want to. There's no need to do that. You can just apply the chain rule combined with the quotient rule. So this is 2 times u squared plus 1 times the derivative of what is inside the bracket, which is 2 times u, times the lower part minus upper part times derivative of the lower part divided by the lower part squared. We set this equal to 0. This is a fraction. If a fraction is 0, the upper part has to be 0, so there's no need to consider this here at all. So from this it follows that 2 times u squared plus 1 times 2 times u times 2 times u minus u squared plus 1 squared times 2 equals 0. Now we can just do the calculation here. So this is 8 times u to the power of 4 plus 8 times u squared minus 2 times u to the power of 4 minus 4 times u squared minus 2 equals 0. Okay, just combining what we can leads to 6 times u to the power of 4 plus 4 times u squared minus 2 equals 0. So this is it. So this is it. This is the equation. Take your calculator and solve for u. You will see you will get 2 solutions, and since we assumed from the very beginning, consider the picture we had at the beginning, we of course assume that u equals, that u is bigger than 0. So the only solution that remains is u equals 0.578. So we've seen q equals minus u squared minus 1. Plugging the result we found for u into this formula leads to q equals minus 1 over 3 minus 1, which is minus 4 over 3. And this is it. I hope this clarifies all the problems with this exercise. Thanks for watching.